I will start the discussion with the dual network. The two electrical networks are said to be dual of each other when the mesh equations of one network is equal to the node equations of the other network and vice versa. Means if one thing or one network we are representing in the form of the mesh equations, we can convert that into the form of the node equations or reverse of that. Means what? The dual networks are based on the two basic principles, which is nothing but the KVL and KCL, that is Kirchhoff's voltage law and the Kirchhoff's current law. The circuit equations of the dual network are similar in the form, but variables are interchanged. Means its variables are interchanged. Means inductor will become capacitor, resistance will become conductor, and similar things I will discuss in the due course of the time. Is it right? Yeah. For example, we consider the two networks. One is RLC series circuit excited by the voltage source, which is this circuit. Here is the voltage source, here is resistance, inductance and capacitance. Its unit is ohm, its unit is henries, and its unit is a farad. That we are considering in the series circuit having its current as IA. And other is the parallel GCL circuit, that is conductance, capacitance and inductance circuit excited by the current source, which is this. This is excited by this current source, and which is I shown in this figure. In this particular case, whenever this current is flowing through the circuit, at that time voltage VB will be developed across this case. What I have done for this part, I have given the names as VA, RA, LA and CA, and for this case I have given the name as IB, GB, CB and LB, and its developed voltage will be the VB. That is nothing but voltage developed across these branches. Is it right? That I will justify. And here, how are the equations? First, we will try to derive the equations. Now here, this applied voltage may be the AC or maybe the DC. Generally, it doesn't matter, and we can have the equations for both cases. The equations for series RLC circuit, but here analyzing the circuit during this particular part is nothing but this circuit. Generally, it is preferred to have a DC source here. Is it right? In that case, how are the equations? How are the equations? Here, if we are applying the KVL, if we have taken the current as clockwise, this will be the negative terminal, this will be the plus, this is plus, and this is minus again, this is plus, and this is minus again, this is plus and minus again. If we are applying the KVL to this circuit, how will be the KVL? This first is this voltage, that is negative to positive plus VA. Then we are traveling from positive to negative, which is minus. Its voltage into its current. Its resistance is RA into IA is voltage developed across that. Similarly, the current flowing through the inductor is given by expression current flowing through the inductor and voltage developed across inductor. These concepts are there. The voltage developed across inductor is always given by the formula L into di by dt. This is the formula for voltage developed across inductor, L into di by dt. In this case, the voltage developed across inductor is L. L is nothing but LA, and I is nothing but IA. dia by dt is nothing but the voltage developed across this inductor. In the similar way, the voltage developed across capacitor is given by the formula. It is 1 upon C integration of I of t dt is the formula. Integration of I of t dt is the formula. T is nothing but variable with respect to time. This is I, or sometimes it can be written as I of t. Means it varies with respect to time. Is nothing but this I is nothing but instantaneous value, one and the same thing. Means here in this case it is 1 upon CA. In place of CA, because its capacitor's name is the CA. Integration I of t, that is nothing but I of dt, which is equal to 0, because summation of all the voltages is equal to 0. That is the equation. But here in this case, integration is taken from minus infinity to t, because we are interested in the calculation of the current in the circuit at the existing time, or voltage across the circuit at the existing time. That's why it is up to the E. If we are simplifying this equation, we are shifting these terms on the next right hand side. In that case, this term will become plus, this will become plus, this will become plus. The CL, it is L into IA, and this term will be as it is. This term is divided into the two parts. 1 upon CA 0 to t I of t dt, and it is a plus. It is 0 minus infinity to 0. Means it is broken into the two parts. One is minus infinity to 0. I have separated it as 1, and then 0 to t I have separated it as second. Now here, this part is nothing but the initial voltage available on the capacitor. Means if we are charging this capacitor, before applying this voltage, some charge may be available across this capacitor. That voltage is nothing but Vc of 0 minus. Means before switching or before turning on the circuit, whatever the voltage available across this capacitor is nothing but that particular value. If this is one equation, if we are applying the KVL to this RLC series circuit, this VA is equal to IA into RA plus LA into DIA by dt plus 1 upon CA into integration of 0 to T IA into dt plus it is VC of 0 minus. There is voltage across capacitor before starting the circuit or before turning on this particular circuit. This is one equation. In the similar way, we can have what is my aim? My aim is the comparison of the two equations and finding the equivalent element which can be used in the dual network. That is the case. Generally, this discussion may not be asked in the examination, but just here moral of the story is nothing but we want to compare the two equations and we want to find out the equivalent elements in this particular case. Similarly, if we are considering the parallel circuit, in that case, this is the parallel circuit, and if we are applying, this is node 1, this and this, because between these two elements nothing is connected. This is something like this structure and this may be something like this structure, and we have the two nodes only. This is one node and this is the other node, which is ground node. And in this particular case, if we are applying the KCL here, if we are applying the KCL, that is Kirchhoff's current law at this particular node, in that case, what is the KCL? Incoming current is equal to outgoing current. Incoming current is this current, and here these currents are the outgoing currents. Means if we are applying the KCL here, this incoming current, that is IB, is equal to outgoing current, that is current in this branch, and this branch. Here, what is the value of the current in this branch? How we are finding the current? Potential difference divided by impedance. Potential difference is nothing but the voltage available at this point. Voltage available at this point, that is nothing but its potential VB, because in this particular case, everything we are trying to mention in terms of the B, that's why it is a VB. Is it right? It is a VB divided by its resistance. Its resistance is RA. But here, this 1 upon RA can be represented as its conductance, that is ZB. That's why the VB into ZB will be the current flowing through that particular element. VB into ZB is the current flowing through that particular element. We see here, this is the current flowing through this branch, this is current flowing through the capacitor is given by the formula dq by dt, that is rate of change of current is nothing but rate of change of charge is nothing but current flowing through the circuit, that is dq by dt. What is the q? Q is nothing but C into V. This is C into, it is dV by dt is the formula for the current flowing through the capacitor. The same thing I have tried to represent here. Current flowing through this capacitor branch will be, this is CB into dVB upon dt plus. Current flowing through the inductor is given by expression, it is 1 upon L, integration of it is V dt. Integration of it is V dt or V of t dt is the expression. The same thing I have tried to mention here is 1 upon LB integration of minus infinity to t VB into dt. Again, we will divide this integration into the two parts. One is from 0 to t and other is from minus infinity to 0. Is it right? This value as it is, this value as it is here. This value will become the same as it is, but this value is nothing but the current stored in the inductor. Because the inductor and capacitor are the energy storing elements or energy storing devices. Inductor stores the energy in terms of the current and capacitor stores the energy in terms of the voltage. You see here, the energy stored in terms of the inductor is nothing but L into ILB of 0 minus. Means here, the energy stored in the inductor or charge available on the inductor before starting this particular circuit is this particular case. Is right? Now, what is our aim here? We are comparing the two equations and we want to conclude something. Because in the dual network, how these equations are prepared, that is not important in case of the duality. From these equations, how we are drawing the inference, that is important. But the inference we are drawing here, if we are putting the two equations as it is, look at here. If I am copying those equations, here, this is the equation number 1. This is VA, IA into RA, that equation I have taken here, and this IV, second equation I have taken here. If we are comparing these equations, this voltage source is replaced by the current source. This voltage source is replaced by the current source in the dual network. Voltage source is replaced by the current source. Means here, if its value is the voltage V, then its current will become, that is amperes. Volts is the value, then its current become ampere. Means if it is a 2 volt source, That source will be replaced by the 2 ampere source. Means magnitude will remain the same, thus unit is going to change and units will be the dual unit. Unit for voltage in terms of the voltage, volts is the unit, and in terms of the current, the amperes is the unit. Is it right? That we have to take care. Here the resistance is replaced by the conductance. Resistance is replaced by the conductance. Here in this particular case, if it is a 2 ohm resistance, then that 2 ohm resistance is replaced by the 2 mho is the conductance in that particular case. Similarly, inductance is replaced by the capacitance. Here the inductance is replaced by the capacitance. This capacitance is replaced by the inductor. This capacitance is replaced by the inductor. Is it right? This current is replaced by the voltage. This current is replaced by the voltage. And finally, in some cases, we may have the switch something like this. If it is a switch is going to close at t is equal to 0. The same thing can be represented something like this. The same is the switch, but that switch is going to open because already the switch is closed. If it is switch is going to close, here the switch is going to open. That I mean to say, means in some cases, if the switch is going to open the switch, here if it is going to open, here it is going to close. And reverse is the case. Here if the switch is already closed here, in this particular case, switch is closed and going to open. In this particular case, reverse is the case. Switch is open and the switch is going to close. That kind of the concept we are going to use in this particular case, and that is nothing but these elements are known as the dual elements. And this is the basic background we must have while discussing or while studying or while understanding this preparation of the dual networks. Means voltage source is dual is the current source, resistance is dual is conductance, inductance is dual is the capacitance, capacitance is dual is the inductance, loop currents is dual is the node voltages, and open switch is its dual is the switch is going to close. These are the dual parameters, and if we are aware of the dual parameters, calculation or preparation of the dual network is not the difficult thing. Is it right? Now here, this point is the point of discussion, important point of the discussion as far as the dual networks is concerned. Here I will discuss the procedure for the preparation of the dual network. Is it right? First I will read out the procedure in one go. The understanding of this procedure, it may not be possible, but while going to the second example, I will try to explain everything related to the procedure. How is the case? While finding the dual networks, first point in this conversion is place a node at the center of each mesh or each loop in the circuit. Means what we have to do, if we have the circuit something like this, here is the voltage source, suppose here is the voltage source and something like this circuit is there, then first find out the number of the loops available in this particular case. In this particular case, we have the 2 loops. Is it right? Because what we have to do, we have to place one dot here and another dot here. That means means of the first line. Place a node at the center of each mesh. At this mesh, we have placed one node, and in other mesh, second node. Then what is the second point? Place the reference node or ground node outside the circuit. Here, somewhere here, we have to assume another node, which is generally known as the ground node. Draw the lines between the nodes such that each line crosses an element. Means we have to draw the line from this particular node to the ground node, this particular node to the ground node. Maybe this is common. If it is common, then we have to connect between the 2 common nodes. Then we have to draw the line from this, and we have to draw the line from this, and then we have to prepare this kind of the approach. Is draw the lines between the nodes such that line crosses each element. Replace the element by its dual. Means here, if it is a voltage source, then this voltage source will be replaced by this connection, and it should be replaced by its dual element, and voltage source is dual element is the current source. That kind of the approach. We will replace each element by its dual pair, and finally we will calculate the polarity of that voltage source, or maybe the polarity of the current source, which is in the dual network. We have the 2 rules for that. The voltage source drives the clockwise current in the ith loop, then place a current source with outgoing current towards the ith node. That is the conversion. How this is, I will discuss directly in the problem itself. Just I will read out the second statement. The current source drives a clockwise current in the ith loop, then place a voltage source with positive polarity at the ith node. That is the concept which I mean to say here. Is it right? Now here, I will take one example and we will try to understand these points and which are useful for the preparation of the dual network. Believe me, this is very small point and just we are trying to convert the given network into its dual network that we are trying to understand here. For that case here, I have taken very simple circuit to begin with. The dual network for the network shown below. Draw the dual network for the network shown below. Means for this given network, we want to draw its dual network. How is the procedure? I will read each point one by one and then we will try to understand here. What is the first point? Place a node at the center of each mesh. Means what we will do? We will put one node here, second node here, and one node outside here. I will give some name to this node A and some name to this node, that is node B, and this will be our ground node, our reference node, which is the node C. In this way, we will use the nodes. Is it right? After that, what is the second point? Second point is draw the lines between nodes such that each line crosses an element. Here we have to be little careful. Whenever we have, this is node, one node, this is another node, and this is the ground node. Here, this branch is not the common to any loop. This branch is not the common to any loop. Is it right? That's why this element will be connected between this node and the ground node. This is again not common to any loop. It is only belongs to the loop 1. That's why this element will be connected directly to the ground node. This is not the common element. It is connected to the ground node. But this current source, it is common to this loop and this loop. In that particular case, we have to cross the line from this node to this node covering this particular element. Are you getting me? Means only in case of the common element which is common to the two loops, we have to draw the line between those two loops in this particular way. Is it right? And again, this is not the common, then from this node we will connect the elements and so on. I will show these things. Just I have made some animations here which will make you understand in the better way. Here we have taken one node here, this is the node A, we have taken another node here, this is the node B, and this is, I have taken one node outside this particular figure which is the ground node, and this node is treated as node G. Which one? Now I am trying to cover each element. Means this is not the common, that's why I will take the line from the node A and I will connect to the node G, then I will take this line in this fashion, because whenever it is a common, then it will go between these two nodes, otherwise it will directly go to the ground node. Means something like this. This is one line, because each and every element we have to cover, because each element we are converting into its dual. It is not related to the branch, it is related to the elements. You see here in this particular case we have, this is one element, second element, third element, means fourth, fifth, sixth and seventh. Means for each element we have to draw one line. Is it right? This is the second line, this may be the third line, and all these three elements, this is number 1, this is number 1, number 2, number 3. These three elements are not common to any other loop. That's why these elements are taken from this node and connected directly to the ground, which is the part of the dual network. Is it right? Similarly, between this current source is available between these two nodes, it is common. That's why the line should be drawn in this particular from the node A to the node B, and this approach is known as the node approach for conversion of the dual network. This is the fourth line. Then here if I am covering this particular element, second element and third element, in that case the connections or lines should be drawn from the node B towards the ground node. Means something like this. This is the one line, this is the second line, and this is the third line. Means in this particular way we are preparing its dual network will be something like this. How will be the dual network? Here will be the one node, this will be the another node, this will be the third node. One node, second node, third node. You see here we have one element here, maybe something like this. We have the second element here, maybe something like this. We have the third element here, it may be something like this. Then this element is available between A and node, means this is A node and this is B node. Then we have another element here. Then here all these elements must be connected here, here and here, because 1, 2, 3. Look at this 1, 2 and 3. These 3 branches are parallel, something like this. This 1, 2, 3 branches are parallel towards this particular node. Only difference is that this capacitor is replaced by, this capacitor will be replaced by the inductor of the same value, 1 Henry inductor. This voltage source will be replaced by the current source here, and this inductor is replaced by the capacitor here. This current source will be replaced by the voltage source here. This resistance will be replaced by the conductance here. This inductor will be replaced by the capacitor here, and this capacitor will be replaced by the inductor here in that particular way, and we will have its dual network. Is it right? How will be the figure? Figure will be something like this. Again, I have given some animations here, and we will try to understand how to convert this network into its dual network. Is it right? Here I will start with the discussion again. What I have done here, I have taken this node, A node, B node and this ground node as it is here, and I will remove each element from here and I will connect in the parallel fashion, and for that particular case I will refer this particular figure. Is it right? Now here in this case, if we are removing this particular line, that is 5 volt, how it will be? I am removing this. Means here, this voltage source I am taking into the consideration where this voltage source is connected. This voltage source is connected between this point. Means here, if I am converting this current source to the voltage source to the current source here, in that particular case, current source to the voltage source, that source will be connected between the node A and the node G, and its value is a 5 volt. In place of that, it will become 5 ampere. How will be its direction? That we'll see later on. This here, in this particular case, if I am replacing this particular line here between the A and G node, in that particular case, how it will be, that I will try to show here. If I am removing that, it will be here. It is connected between the A and G, this line. It is connected between the A and G line, which is somewhere here. This is that particular case. Is it right? The second thing which I will remove is nothing but this 2 Henry. This 2 Henry, and this 2 Henry is here, and it should be connected between the node A and node G, and this inductor should be replaced by the capacitor. Yes, we have to connect the capacitor here. We have to connect the capacitor here, something like this, and its value will be same as the value of this inductor, which is 2 Henry is the inductor. This here the capacitor value should be the 2 farad. That I mean to say here. In this particular case, the capacitor is the 2 farad, which is connected here, this value. And if I am coming to this element, if I will remove this line, means indirectly, why the animation I have shown? Because how each element is converted, that I am trying to show. You see here, whenever this element is there, this 1 farad should be connected between the A and G, the node A and G. This is node A and this is node G, and this capacitor should be replaced by the inductor. This capacitor should be replaced by the inductor, and it is connected between the A and G line, which is something like this. Is it right? Then this particular line is available between A and B. In place of this line, if I want to find out its dual, means its dual should exist between the A and B. Here is the current source, means here should be the voltage source. Here should be the voltage source, something like this. It is of 1 ampere, it should be of 1 volt. How is this direction? That I will discuss later on. How is this direction? I will discuss it later on. Then again, I will consider this 3 elements, that is 1, 2, 3 again. If I am starting with this, if I am replacing this resistance, 2 ohm resistance here, in that case it should be connected between the B and ground. This is B and ground, and this 2 ohm resistance should be replaced by the 2 mho conductance. It is something like this. This is 2 mho is the conductance of this particular path, which is connected between this point. This here, for the reference, I have taken this figure. I am trying to discuss about this. It is available here. It's in place of this, we are trying to draw this particular line. Similarly, if I am going to next 1 Henry, it is 1 Henry. It is connected in this fashion. It will become parallel between the node B and node G. Node B and G, but it is inductor. Inductor should be replaced by the capacitor. It is something like this. This inductor should be replaced by its capacitor. Is it right? And finally, this element, which is nothing but the capacitor of 4 farad. capacitor of 4 farad should be connected between the B and G, that is node B and node G, means somewhere here B and G, and this capacitor should be replaced by its inductor of the same value. Means here the capacitor is of the 4 farad, it is inductor of the 4 henries. Means here what we have to do, first it can be calculated in single step, nothing is required, nothing complications are required in this particular case, no complications are there. Are you getting me? In this particular case, how are the methods or how are the things? Here first we have to place 1, 2, 3 nodes, something like this. Here this is the first line, this is the second line, and this is the third line which we have, and this may be the fourth, this may be the fifth, this may be the sixth, and this may be the seventh, in this way, which is shown something like this in this particular case. And then from this figure directly, here between the A and G, the source between this A and G, again this 1 farad. This 1 farad is replaced by 1 henry. This 2 henry is replaced by the 2 farad. That's it. This 1 ampere current source will be replaced by 1 volt. This 2 ohm is replaced by the 2 mho. 1 henry is replaced by the 1 farad. And this 4 farad is replaced by the 4 henry. You see here, this is the original network and its dual network is something like this. This I will discuss additional point, how to find out these values or direction of this particular current source and direction of this particular voltage source, that I will discuss, and that is the end of this particular problem. In this case, now look at the rules, whatever I have shown in the procedure, the rules I have brought here again. The voltage source drives the clockwise current in the ith loop. Here is the voltage source. How is the direction of this current in this particular loop? Positive current. Here, if I'm taking this, means its direction will be the clockwise. If it drives the clockwise current, the voltage source drives the clockwise current in the ith loop. Ith loop means we have the 2 loops. This is the first loop and this is the second loop. If it drives the current in the first loop, the voltage source drives the current in the ith loop, that is nothing but the first loop. Then place a current source with outgoing current towards the ith node. Here is the A node or first node. This is the second node. If it is the first loop, then this will be the first node. This is the first node. Means what we are interested, then the place a current source with outgoing current toward the ith node. You see here the current direction should be something like this, which is the upward. The current direction should be the upward, because how it should be replaced, the current source with outgoing current toward the ith node. If it is ith loop, first loop, means first node, it should be toward the first node. Means the direction of that current source must be upward. That is nothing but the towards node A. That I mean to say. Similarly, how is that polarity, which I will show, otherwise I will show that here. This is the polarity which I have tried to show here. You see here, if we have the clockwise current here, in that particular case, the current source which will draw here, its direction must be toward the first node. This is the first node, that's why its direction should be toward the first node, that is upward direction. Is it right? Similarly, if we have the current source drives the current in the clockwise direction in ith loop, here is the current source. We can consider this loop or this loop because it is common. If we are considering this loop, how is the current clockwise? Positive current clockwise. Current source drives the clockwise current in the ith loop. Clockwise current in the ith loop, that is in the first loop. And anti-clockwise current in the second loop. Because here in this case, if we are taking something like this, it is clockwise. It is opposite to that. You can consider this. In that case, reverse should be the things. Otherwise, you can consider in the first loop itself. That is your choice. If we are considering in the first loop, if it is a clockwise current in the first loop, then place a voltage source with positive polarity at the first node. This here, the polarity of this source should be positive at this side and negative on this side. That I mean to say. If I have taken the reference of the second loop, in this case, how is the current? Current is not the clockwise. Current is not the clockwise in the second loop. If the current is not the clockwise, then reverse should be the thing. Reverse should be thing. Means voltage should not be at that particular node in the second node. Means it is reverse at the second node, means negative at the second node and positive at the first node. Here use this mesh direction or use mesh direction. The answers will be the same in your case. Here what I mean to say, I will repeat once again. The current source drives the clockwise current in the ith loop. If it is clockwise current in the ith loop, then place a voltage source with positive polarity at the ith. It is the first loop, then positive polarity at the first node. Otherwise, reverse. Suppose if this direction is upward. Suppose if this direction is upward, and if I am taking the clockwise current here, it is not the clockwise current source that drives the clockwise current. It is not the driving the clockwise current. It is driving the anti-clockwise current. In that particular case, voltage source with negative polarity at the ith node. Means here should be the negative and here should be the positive if this current source is the upward direction. Is it right? That's why here its polarities will be, here is the plus polarity and here is the minus polarity, which is nothing but the conversion according to those rules. Is it right? And if I am remodifying this figure will be something like this. This is the dual network of the network which I have discussed previously. This line, what I have done? The same circuit I have drawn something like this. The same circuit which I have tried to draw something like this. Here will be the inductor, here will be the capacitor, and here will be the current source, something like this. And again, here will be the one element, here will be the capacitor, and finally here will be the inductor. In that way I have tried to mention, which is nothing but the circuit which I have tried to show in the next figure. This is the final answer. Means whatever we have the network, this network, the given network is this. We have followed this procedure, which is something like this figure, and from this figure we will get this figure, and its final figure will be something like this. This is the conversion of any given network into its dual network. This is the procedure for that. Is it right? So here I will come back to you. I will take the questions from your side, and what I will do again here, I will take the same circuit in the next example, and we will convert the same circuit into the original circuit using the similar concept again, which is nothing but the concept of the duality. Using this concept again, we will convert into the original network. But before that, I will take the questions from your side. Is it right? This is the first example. In this particular case, I will go to the next example. Which is something like this. Is it right? This is the next example. Now, just give me a minute. Yeah. This is the next example. So here in this case, draw the dual network for the network shown below. This is the given network now. And we want to convert this network into its dual network. Now look at the procedure. Before showing the animation, I will discuss this point. Here is one loop. This is one node. Here is another loop, second node. It will be third node. Here will be the fourth node, and here will be the fifth node. Means we have to place one node in each loop and one node outside this figure. Is it right? This element is not the common for any loop. Means it will be connected here, something like this. This element is common for 1 and 2 loops. This element is common for 1 and 2. It should be drawn something like this. This element is again common to 1 and 2. This will be connected something like this. Is it right? This element is common, again it will be connected something like this. This element is again common to these loops. It will be connected something like this. This element is not the common. It is independent to this last loop. That's why it should be connected something like this. Again, this element is again not the common. It belongs to the loop 3 only. If I am taking this is as loop 1, this is as loop 2, this is as a loop 3, it is as loop 4, and it is as the loop 5. This element is independent. Means it should be connected to ground, maybe something like this. Or if you are feeling this is difficult, you can connect in this way also. That is the case. You can connect here itself, or you can connect, and in that particular case, series and parallel combinations can be taken, and its relevant things can be found out. Here, look at how is the case. This is the first loop, first node, which is node A. Second loop, second node, which is node B. Third loop, third node, which is the node C. Fourth loop, fourth node, which is the node D. Fifth loop and fifth node, which is the node E. And we are taking another node, which is a ground node outside this particular figure, and we will call this node as the node G. how will be the conversion of the element and how will be these elements connected in the parallel fashion? I will show here. This is the first element, that is current source, should be connected between the node A and node G. The capacitor which can be replaced by the inductor, and that should be connected between the node A and B. The inductor which will be connected between the node B and C, and that should be replaced by the capacitor. The next is the admittance which is of the 2 mho here. This admittance is the 2 mho. It will be converted into the resistance and it should be connected between the node C and D. Next, capacitor is available between the node D and E. It should be connected between the node D and E, but it should be converted into the inductor. And finally, this inductor, it is available in the outer loop. That's why it should be connected between the node E and this particular node, which is nothing but the ground node. And finally, the element which is remaining is this voltage source. This voltage source, it should be connected between this capacitor, this point C and this particular the point G. It can be drawn something like this. It can be drawn something like this. It can be drawn something like this, or maybe here only something like this. That is your choice. If I'm taking here, it will be connected between the C and B. Means we are covering that particular element. That's it. Nothing else. It will be something like this. This voltage source will be replaced by the current source, and that current source must exist between the point which is the C and this ground point. Is it right? The similar discussion I will do in the next slide. Is it right? It is somewhere here. This is the case. Now in this case, what I am trying to do, the figure from the last slide just I have copied. I will take these nodes A, B, C, D here and I will connect the respective element between those lines. What I have done? Now look at here. I have taken this node A here, node B here, node C here, node D here, node E here, and this ground node I have copied here. Here, in place of this current source, I will connect the voltage source between the node A and G. This here, I will connect the voltage source. Its polarity I will discuss later on. Then here, this element is the capacitor should be replaced by the inductor. It will be connected here. This inductor will be replaced by the capacitor. It will be connected here. Then this impedance or admittance, there is 2 mho. It is between C and D. This is C and D. It will be connected here. This is the conductance, and it will be converted to the resistance, which is of the 2 ohm. This between D and E is the capacitor. Between D and E is the capacitor that should be replaced by the inductor. And between the E and ground, this is E and ground, we have the inductor. That inductor will be replaced by the capacitor, and which will be connected something like this. And between C and G is the voltage source. Between the C and G is the voltage source. That voltage source will be replaced by the current source, and the direction of this current source and the polarity of this voltage source I will discuss in the due course of the time. Is it right? Now here I am starting with this first. I will remove that first line. Why I am removing these lines in the animation means you must able to understand which conversion I am doing. I am doing this conversion first. Just I am using the conversion for this 5 amperes. This is 5 amperes. It will be connected between the A and G, and that source should be the voltage source. It is a 5 volt. It is 5 ampere is replaced by the 5 volt. Is it right? Then between A and B we have the capacitor of 2 farad, and that should be replaced by the inductor of 2 Henry. This element will be replaced by something like this. Then between B and C we have the inductor of 1 Henry. It will become the capacitor of 1 farad. It should be replaced by the 1 farad capacitor. Then between the C and D we have the resistance or conductance of the 2 mho. It will be replaced by the resistance of the 2 ohm. Between these points here we have the resistance of the 2 ohm. Between the D and E we have the capacitor of 1 farad. That will be replaced by the inductor of 1 Henry. And between the point E and the ground, we have the inductor of 4 Henries. That inductor will be replaced by the capacitor of 4 farad. Is it right? Now pending is this only. Pending is this only, which is nothing but the conversion of this voltage source. Here, that voltage source will be converted into the current source, but it will be connected between the C and G. C and G. This is C and this is G. This here will be that current source. This voltage source will be replaced by the current source, which is of the 1 ampere. Which is 1 ampere. Now we will discuss about how is this polarity of this voltage source and direction of this current source. Is it right? Again, I have taken those guidelines or those points. What are the points here? The voltage source drives the clockwise current in ith loop. Where is the voltage source? Here is the voltage source. Now here, if I have taken this loop, its current is clockwise. It is not generating the clockwise current. Is it right? The voltage source drives the clockwise current. It is not driving the clockwise current, but its actual current will be anti-clockwise. Is it right? Then place a current source with outgoing current toward the ith node. ऐसा है तो ऐसा करना, ith node की तरफ रहेगा. अगर clockwise है तो. If it is anti-clockwise, because actual direction is anti-clockwise. That's why the direction should be towards the ground node. Means something like this. Its direction should be towards the ground node, which is something like this. Is it right? It is towards the ground node. It is something like this. Thus, if I am coming to this current source again, look at this. The current source drives a clockwise current in ith loop. In this case, it drives the clockwise current in the ith loop. Yes, it is. Then place a voltage source with positive polarity at ith node. This is the which loop? First loop. And it should be positive at the first node, which is the A. That's why this is the polarity for that. Means it is the calculation of the polarities or directions of the currents will based on these two rules.